Today we're going to be talking about coordinate proofs. And don't freak out just because of the word proofs. What you're doing with coordinate proofs is you are using a set of axes to prove theorems involving, by using, I should say, by using the distance formula, midpoint formula, and the slopes of lines that are parallel and perpendicular. So you're going to use all of the algebra that we've been learning through the chapter to prove certain theorems that we already know are true, just now we can use algebra to prove them. So first we start out by laying out different figures on the coordinate plane. So supply missing coordinates without introducing any new letters. So this is the idea where I'm going to look at what the picture I have, and I got to figure out different coordinates or coordinates for E, but involving just what I have. So D is 0A. So from 0, 0, which is our origin, that's why it's labeled O, all the way up, that's A units long. So that means this is a 30, 60, 90 triangle because I know I have a right angle there because it's on the axes. So the side opposite the 30 degree is A. The side opposite the 60 degree is going to be A root 3. So from the origin over along the x-axis is A root 3. I don't go any up on the y-axis. Next one, supply the missing coordinates without introducing any new letters again. So now I have an equilateral triangle. And they tell me it's an equilateral triangle. So I know from the origin over this distance is B. Since it's equilateral, this distance is also B. So I have negative B because I'm in the negative area, and I have 0. Now I have to figure out what the height is, though, because that's going to be my y-coordinate for point I. Well, let's think about what we have. We have 30, 60, 90 triangles again. You guys know how much I love those. So the side opposite the 30 is B. Therefore, the height is going to be B root 3. B, not 6 root 3. So B root 3. Now, proofs involving them. And don't freak out. They're not as bad as you think. I think usually guys like these more than the other ones that we've been doing. So prove the medians drawn to the legs of an isosceles triangle are congruent. So we are given that picture and we need to prove that ON is congruent to MQ or QM. So you're not going to be doing like the given and the proof. We have the picture. What you're going to be doing is using the algebra. We know that these are medians, so I need to find the coordinates of M and N. So M, the coordinate of M, since that's the midpoint of segment OP, is 2A plus 0 over 2 and 2B plus 0 over 2. And yes, I want you guys to be showing me that work. Just humor me and show me that you're finding that midpoint so that M is AB. And then find the coordinate of N. So 2A, 4A plus 2A over 2 and 2B plus 0 over 2. So I get 6A, so that's going to be 3A, comma, B. Now notice how they chose the points for this proof. They chose the points, they didn't make Q just A and P just A and B. They chose to make it multiples of A and B so that when I found the midpoint M, they weren't fractions. Because if I made P just points A and B, M would have been 1/2 A and 1/2 B. And that's going to get a little bit more challenging for us to work with. Now, how do I prove two segments are congruent? Using algebra, distance formula. So let's find ON. So N was the coordinates of 3A and B. So ON is the square root of 3a minus 0 squared plus b minus 0 squared. So I have the square root of 3a minus 0 is 3a squared is 9a squared. B minus 0 is b squared is that. So then find QM, and that's the square root of 4a minus a and b minus 0. So 4a minus a is 3 squared is 9a squared plus b squared. So ON is congruent to QM by using our distance formula. Last example, given the right triangle with M being the midpoint of the hypotenuse, M, and I need to prove that M is equidistant from the three vertices. So when I draw this segment OM is going to be congruent to all three of those. Those three segments are all going to be congruent. So what we need to do is we need to find coordinates. Because part of it is you're going to have to, part of coordinate proofs is you need to lay out the picture and give me reasonable coordinates. Let's make point A 2A and 0, and B 0 and 2B. Because then when I find the coordinates of M is halfway in between them. So I have 2A plus 0 over 2 and 2B plus 0 over 2. I'm going to get integers, A and B. Now what we need to do is we need to show that M, let's fill in our coordinates, AB, is equidistant from all three vertices. Well, since M is the midpoint, BM is congruent to MA. I need to show that BM, which equals MA, is equal to OM. So let's find what BM is. BM is the square root of A minus 0 squared plus 2B minus B squared. So that's the square root of A squared plus B squared. Let's just show, just for fun, what the distance of MA is. MA is 2A minus A squared and B minus 0 squared. So that's the square root of A squared plus B squared. So I've shown those two are equal. Now I need to show that OM equals that. OM is the square root from the origin, so that's 0 for x, b minus 0 for y, which is the square root of a squared plus b squared. So all three end up being equal. So we have proven, since all three distances are equal, that it is equidistant from all three vertices. All right, there are no formal lesson questions. This is our last video of the year. Please be sure to fill out and summarize the lesson. Honestly, I couldn't think of any good lesson questions. So please make sure you summarize the lesson on the Google form and make sure that's submitted on time.